Hi, I'm Ronald Knecht. I'm Global Business Development Manager for QUINTOLUBRIC. Welcome to this information session about fire-resistant hydraulic fluids. What we like to discuss today is about water-free fire-resistant hydraulic fluids and in fact compare them with mineral oil-based hydraulic fluids and compare their fire resistance. So what you see on this picture is what we like to avoid by all means, which is in fact the factory burning down. Of course, there is a risk for staff, but there is also a big capital loss involved. You cannot produce, you cannot supply customers. There's a lot of reasons to get a fire in your plant. One of the reasons we can do something about is a fire caused by mineral oils. Mineral oils are high viscous gasoline, have a tendency to evaporate easily, give vapors, highly flammable, and give explosive ignitions. So that's why we always recommend for fire hazardous situation to use a fire-resistant hydraulic fluid. If you compare hydraulic fluids with one another, so the water-free versions for fire-resistant application, so the classic, so the standard fluid is a mineral oil-based hydraulic fluid. When it comes to normal parameters like thermal stability, fluid maintenance, component life, the fluid is performing well. It was also cheap, but the moment you get a fire, the total cost of operation goes into the minus simply because an oil is easy combustible. Alternative fire-resistant fluids are phosphate esters. What you can see is that they are a very good fire resistance by itself. Thermal stability is also quite good, but there is some drawbacks on environmental because they are CMR material. Fluid maintenance because of the aging, they generate aggressive acids. And also the price, which is about 15 times as expensive as a mineral oil. So the alternative, the best solution is a polyester kind of fluid like QUINTOLUBRIC 888. It's fire resistant, not as good as a phosphate ester, but much better than a mineral oil. It's environmental friendly, so it's biodegradable, and it's friendly when it is wasted in soil. Thermal stability, fluid maintenance, component life, comparable to mineral oil. It's a bit more expensive, but in the end, the total cost of operation will be deeply into the positive compared to mineral oil or phosphate esters. Some key points for fire resistance. If you look at this type of fluids, they are organic, they are water-free, so there will be a moment that they will start to burn. So if you compare those fluids, mineral oil with a polyester, you can see that the mineral oil has a tendency to explode, where a polyester has a tendency to give small flames there where it is in contact with the hot surface and gives you control over the situation. The smoke formation, timed ignition, propagation of flame. So for instance, when you have a rupture in your hose, there's a jet coming out, it is ignited at the end. The propagation, it's not running back to your system. To test this fire resistant fluids, there's a lot of ways. One of the best defined ways at the moment is Factory Mutual. It's an American insurance company. They really follow your process, take a sample, test it in the laboratory, and when you meet their requirements, you get a piece of paper showing that you are fire resistant. And in the end, when they do a risk assessment of a plant, this might result in a reduction of a premium. So there's always also a way to explain fire resistancy by simply looking at physical parameters. Mineral oil compared to polyester QUINTOLUBRIC. 3 parameters: out ignition temperature is the temperature where an oil starts to ignite without external ignition sources. Specific heat, which is the energy needed to heat up the fluid for 1 degree, where you can see that the mineral oil is about 15% lower than a QUINTOLUBRIC. Heat of combustion, so the energy that is released once oil is burning, where you can see that the mineral oil is about 15% higher in combustion energy than a QUINTOLUBRIC 888. So if you take those parameters together, you can conclude that the mineral oil generates more heat, where the specific heat is lower, so it needs less energy to heat up, to end up at the temperature, out ignition temperature to start burning. And this means that the oil is more able to keep itself burning once it is burning. And that we have tested or demonstrated in a pool fire test at a customer, where we took a bowl, a steel bowl, filled it with 400 milliliters of oil, and we've added a block of red hot steel into the bowl. And what you can see on these pictures is on the picture on the left on the top is that the mineral oil is already burning. We put the red hot piece of metal into the QUINTOLUBRIC. It will start to burn as well because of the heat of the metal piece, but only for 50 seconds, after which you see that QUINTOLUBRIC will extinguish and mineral oil continues to burn, and it continues to burn until the complete bowl is burned away. In this video we have a hot plate tilted at about 500-550 degrees, so way above the out ignition temperature of both mineral oil and the QUINTOLUBRIC. And what you will see is when we pour mineral oil on this hot plate, it gives a vapor, it gives an ignition, and you will get a waterfall of fire once it is burning. So when we're running the same test with QUINTOLUBRIC, you can see that although the hot plate is way above the out ignition temperature of the fluid, you can see that the contact time is too short and there is no ignition of the fluid. So that's control over your situation. In this slide I show you a snapshot to explain why a mineral oil can give this explosive nature compared to polyester QUINTOLUBRIC. This is the 900 degree hot plate, and you can see on the left top picture where mineral oil poured on this hot plate. There's a lot of vapors being formed. Once it is ignited, it gives an explosion, and you can see the fireball taking place, and this fireball is completely filled with burning oil droplets that are, because of the explosion, spread in all directions, setting the whole place to fire. Compared to QUINTOLUBRIC, you can see there is no vapor being formed, and there is a small flame, so there's control of your situation, no explosion. So in a summary, if you compare mineral oil to QUINTOLUBRIC, you can see that the fire-resistant hydraulic fluid allows you to make an easy, swift, or an easy change from potential crisis situation to a safe situation. The polyester does not keep itself burning because of its physical parameters. Personal injury and interruption to production are avoided. Thank you very much for your attention, and I'd like to welcome you in another information session. Thank you.